NASA is launching an artificial star into orbit around the Earth, and here's why. Astronomers typically deal with the very, very large, big telescopes, giant galaxies, and massive exploding stars. But one of the more revolutionary astronomy tools of the decade is a mini satellite about the size of a bread box. The satellite will act like an artificial star for astronomers to observe from the ground, allowing them to more accurately measure a space object's brightness and better understand some of the biggest mysteries of our universe, like dark energy. NASA recently approved the $19.5 million Landolt space mission to launch the mini satellite into Earth's orbit. This is some really awesome science that NASA is supporting. Tyler Ritchie Yoel, postdoctorate researcher at Lowell Observatory, who studied stellar astronomy and exoplanets, told Business Insider, it's something that's going to help out all astronomers, he says. It's a revolutionary new tool for astronomers. The mini satellite, called CubeSat, is designed to orbit the Earth from 22,236 miles away. At that distance, its speed will match Earth's spin, so the satellite will appear fixed in the sky and it will be an easy target for telescopes to track. You won't be able to see it with the naked eye, but to telescopes it'll look like a star. The mission is scheduled to launch in 2029, and it will be the first tool of its kind. This is a really new thing for us to have some sort of an artificial star, quote unquote, up there that we can get and rely on and use. Ritchie Yoel told BI. What makes this artificial star better than the real one is that astronomers will know exactly how much light it's emitting. The CubeSat, named Landolt for the late astronomer Arlo Landolt, will fire lasers with a specific number of light particles, or photons, which astronomers can use to calibrate their telescopes for measuring light. And this can help eliminate a lot of the guesswork that astronomers do now when using real stars to calibrate their instruments. The problem is that there's no way for knowing exactly how much light real stars emit because we can't send a probe to one to actually measure its brightness, Ritchie Yoel said. And moreover, Earth's atmosphere absorbs a lot of light from space, which can also affect astronomers' calibrations. That's why this Landolt mission is so important, Ritchie Yoel said. And if we send up a mission like this, one where we know exactly how many photons and how much light per second is coming from this CubeSat, then we can say we can use it to compare the more precisely measured light from other objects like real stars, she said. The mission is expected to help astronomers measure the light emitted from stars with 10 times the accuracy that current estimates have. And it's like if you were given a 1,000-piece puzzle that only had half the amount of pieces, and then someone gifted you a few hundred more pieces. Landolt will help astronomers catch minute details they've otherwise been missing in the data. How Landolt could revolutionize astronomy. All of our astronomy is based on light, and so we really need to know how much light we're actually receiving, Ritchie Yoel said. You can learn a lot from the ray of light, a star's temperature, its mass, the types of exoplanets obtaining or orbiting it, and whether they could potentially harbor life. For example, knowing how hot a star is can tell you how far the exoplanet must be in order to sustain liquid water on its surface, Ritchie Yoel said. You can learn a lot from a ray of light, a star's temperature, its mass, the types of exoplanets orbiting it, and whether they could potentially harbor life. For example, knowing how hot a star is can tell you how far the exoplanet must be in order to sustain liquid water on the surface, Ritchie Yoel said, and if it can harbor life. Finding more Earth-like planets is just the beginning. Astronomers can also use Landolt to measure light from distant exploding stars, called supernova, that help calculate the expansion rate of the universe. Right now, cosmologists studying the universe's expansion face a huge challenge. They cannot settle on a single value for the expansion rate. Some methods lead to one value while others lead to a slightly different one. This conundrum could be a key to figuring out some of the biggest mysteries of the universe, like understanding the invisible force ripping our universe apart that we call dark energy. So really anything from small tiny planets to the whole scale of the universe relies on our understanding of stars and how bright they are and what kind of light they're emitting. Richie Yole said, "I really do think it would be revolutionary for astronomy." And this was originally published on Business Insider by Jessica Orwig. It's on Science Alert. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.